Hello and welcome to another video on AP Review, and this time we're going to tackle creative development, which is one of these units where they pack a bunch of stuff in, which is kind of similar but also kind of not similar. So one mistake that students might make in thinking that this only applies to the performance task or it's just about building teams, no. This unit also has other things in it which may get you tricked in an exam. For example, it will get you to identify and correct errors in code. That itself is a part of this unit, which is weird because this is the big idea 1, but we learn about code in big idea 3. So how are you meant to fix errors until you know how to code? Well, this is why it's really useful to come back to this unit at the end, because you'll then be able to you'll have more reference points with which to deal with kind of code problems and things like that. So it's really good to reflect on this unit at the end and sort of have a look and say, now I sort of understand it. Now that I've actually created something, I can kind of really understand how collaboration, program function and purpose works, like even how to design a program. Like maybe you got lost in all the details for your building your app and you were like, oh man, this is so complicated. I wish that there was a simpler way to do this. And turns out all the stuff we taught you in Unit 1 was probably relevant to that. So in this way, we're going to take another look at it and then give you some reflection time to sort of understand, okay, how could we have done things better? No doubt you've done your fair share of error checking and debugging by now, but let's go through and see if there's some really good tips in here for you. So let's deal with the first part. The first part is collaboration and design. The focus of this unit is how do teams get together and make stuff? And what is a good way to make stuff? So there are two main areas. The first area is how do we ensure that we get some really great products? And that means let's try our best to get different points of view and think about our users as we're designing things. We're going to collaborate. We're going to try and get everyone's ideas and then improve our work. And the other thing is we're going to look at how teams get together and create things in the design cycle. Right? And this long, complicated sentence, which I've tried to improve with some color, but it's worthwhile looking at it and unpacking it a little bit. When we talk about iteration in our for loops and while loops, iterative should give you now an idea of what the design process means. That we're going around and around in this process to improve. And it's not about going from A to B, but it's about going from A to B a few times, and we keep revising each time. User focus means that we're listening to what the user's real needs are and getting feedback from users on it and improving things. So we use cycles to improve things. And then we can still have room for risk-taking and experimentation. So that's the goal, is a good project should have those things. Let's talk about what a program is. And generally in this course, when they're talking about a computing innovation, they are talking about something that uses a program as the essential part of kind of the intelligence of how it works. So that thing, that computing innovation, could be a self-driving car, it could be a robot, that's doing it's like doing things in a factory. But all of those things are going to have some kind of program to run it, to tell it what to do. Otherwise, it's just a chunk of metal. So the program is the essential part of the intelligence of the thing and how the logic works. So all these computing innovations have a program as the integral part. So it's not just software like that you find in the App Store, which is only a program. You may have a PC, which, technically a PC is it runs software, and you could have a smartwatch, other things. So it's kind of on this this structure of levels. Now you, as a user, you're interacting mostly with the software to make your choices. And that's controlling the operating system and the hardware, right? So these layers are separate from each other, but they all work together. All right, so as we've seen, there's a few different options. It could be a self-driving car, yes. It could be some kind of software that we're using. Or the third option, it could be a concept, right? Such as cryptocurrency or e-commerce. These are kind of computing concepts, not even software themselves. They will use software, but they're kind of concepts of how things could go together. Protocols may fit into that kind of concept. Okay, so let's talk a little bit about programs. So here we have an example from, if you've ever used Code.hs, you may recognize this, but here's an example of a dog, following a path and doing some kind of instructions, right? Your code is basically a series of instructions to tell the computer what to do. And whether it's a self-driving car or some little thing on a screen, they both are basically just following some kind of instructions. So, what is the purpose? Why do we create computing innovations? There's two main reasons why you would want to create a computing innovation. Either you're trying to solve a problem, or you're trying to pursue your interests and you express yourself creatively. These are the two main categories. If you solve a big enough problem, most likely people will be very happy and they'll give you a lot of money. But it's not only about just making money. Sometimes you just want to make something really cool, something you're really interested in, and that's creative expression. So it's these two categories that computing innovations fit into. And if you want to create something useful, you have to understand that not everyone just wants to solve problems. Some people just want to express themselves. And if you look at these AI things for art, like Midjourney, that now provides average people the ability to create artworks without even having to know how to make art. And that's creative, and they can be creative with their prompts. They don't have to spend years and years practicing. They can just express themselves in a new and interesting way. And so that's an example of expression. But if you use Photoshop, that's another example. If you make an app that puts a filter on a face, again, these are all creative expressions. It's not necessarily solving a problem of, hey, the world needed filters. It's just that, sometimes things are fun. All right. So let's get into the part here where we're talking about collaboration. This is the first area. Now, I think some of this will be intuitive. We know that, when we work together, we have to communicate, and we have to not try and hog all the attention or steal the ball, like to use a soccer or football analogy. We don't want to hog the ball. We want to try and respect everyone's talents and perspectives. So hopefully, if we have a good team, we, one, have different perspectives, because if we all just think the same way, then maybe our product will only kind of have one point of view, and maybe someone who's outside our group bubble may have had a different suggestion, which may have been a great suggestion. It's not to say that diversity of talent is going to solve every problem, but it means that we have more options to choose from, more flavors, or more different kind of views on the world. And that is the essence of what we're trying to establish. And so what we're really trying to do is stop our programs having bias, which means it means a kind of an opinion. It's kind of like an opinion one way or the other, or it's not a balanced approach. So we want to avoid that. For example, if the app that we're designing really favors people in cities for some reason, like you can book restaurants, but you can only book restaurants that are in the city, then people who are outside the city or in smaller towns may be unable to use the app. So maybe it's things like that, or maybe it's the writing of your app is very, very small, and everyone who's on your team is a really has perfect vision, but then someone comes along and they try and use the app and they're not that great. Maybe their eyesight isn't that great and they can't read the small writing, and that means that their app is not really useful for them. So trying to get different perspectives is really useful because it can make us think, okay, what's another way I could do this that we can include everybody? Consultation, communication with users is important. Now, this may seem obvious, but it's amazing how people create stuff and they don't test it on real people. They think, oh, I like this, so therefore everyone's going to like this. It's kind of a very ego-driven way to do things, but we tend to want to agree with ourselves a lot, and we can't imagine that anyone will want to disagree with us. But getting information from potential users is really a key element. If you can do this as early in the process as possible, that's the best, because you can get feedback which may help you to avoid some things or change some things early on, instead of finishing your product and then realizing you made a fatal error. So that's another thing. Like, get users, even if they're not working on your team, just get people to play with your app and they might use it, right? So one of the ideas is that you just let them do their thing with the app and then have a look and see how they use it. Maybe they're going to use it in ways that you didn't expect. And if you don't guide them on how to use it, they might show you that, hey, maybe they didn't understand how to go back. Why is the back button so small? Why, maybe they didn't understand that that was what they were meant to do. And next time you would make your app more user-friendly. Okay? So this is the general idea, is that diverse perspectives and teamwork and collaboration will help. Okay, so we can use online tools to collaborate. We can use pair programming. These are all ways to collaborate, and hopefully helps us to get... The goal here is, let's get the best idea. Let's not worry about ego and whose idea it is. The main thing is, let's try and work on the best thing together. All right, that aside, let's go to focus area 2, multiple perspectives, okay? So as we'll get into the process now, which talks about the feedback cycles. We have talked about user focus a little bit, but let's talk about the cycle, okay? The reason why you would want to use an iterative cycle is because sometimes you can't know about the things that may change a project or things that may happen later in the process. For example, like you might do your design and then you make all the screens, and then you realize that the user really wanted to, maybe it was too complicated and there was a lot of reading and users skipped reading a screen, right? And so maybe then you have to go back to the start and say, oh, let's redesign our screens because we clearly put too much writing in here. And so if you want to try and get that done as soon as possible and then go around in another loop, redesign, test it, evaluate it, and think about if you want to change more stuff. So the idea is that we're going to do loops of cycles, not just go from A to B. Okay, and this is pretty good. This is a video on Speak, which is an app that is sort of powered by OpenAI, or at least OpenAI is investing in it, I think. But this is an app for learning English, and this talks about the developers and how they went through a bunch of testing, and their first version of their app was not that great. People didn't really like it, but they did a lot of feedback testing, and so I'd recommend you having a look at that video. All right. Let's have a look at program, function, and purpose. This is where we get into the second half of this, because now that we've finished team building, let's talk more about programs. One part of this course, which will be a tricky part, which is you'll have to explain how a piece of code works. So let's talk about the way code works in a general way. Usually, program statements are run sequentially. You have a statement, it tells the computer to do something. You have another statement, it tells the computer to do something, etc. right? There's one, then the other, and the other. The computer, the programming language you're writing in usually has some commands built in to that language, and it has a way of structuring the statements so that the computer will understand what you mean. Some of these things are familiar between languages, but generally speaking, it's just a series of logical statements which will ask the computer to do some action. Okay, this is software. This is how software works. The model of the way it works, the way a computer works in general, but also the way your programs will run, is that you'll be basically handling some kind of input. You'll be storing some of that input maybe. You might be storing some data as well, based on what your app is doing. And then you'll be doing some processing. Maybe this input requires this thing, so you'll calculate something. And then finally, once you've done this, maybe you'll store some results and do some more processing, and then eventually you're going to display some kind of output. Maybe that's something on the screen. Maybe it's a sound. But output that will tell the user something, and then we can go back and do more, like maybe more inputs, more storage processing. This model is the IOSP model, and it's a very general model for how computers and software works. You can even think of your functions and procedures working this way too. Okay, in the algorithms and programming unit, we've discussed variables, and we have gone through that. So I would refer to you to that video for this stuff. This is just a little quick reminder that I give students at the time, but I'm going to skip that now because we have covered that in another video. Okay. Let's look at this. Now, your program will be, when you write the program, you're going to have to deal with a bunch of different inputs and things that are happening. When your code's running, your user might be clicking on buttons. It might be handling, different inputs. Maybe there's a trigger that happens, an event. But generally, you'll have to be responsive to different inputs, right? So let's take a look at the inputs, what we have, okay? Now, there will be some kind of variety in the inputs depending on your program, but generally speaking, inputs look like this. They could be images, audio, text. It could be touch or movement. It could be events that happen. It could even be from another program which does that, right? So these are all the types of inputs that we have. Think of your phone. What kind of stuff can you do with your phone? You can push buttons, you can tap the screen, you can shake it, you can use the camera. These are all inputs. So the thing with events, your phone has to respond no matter what it's doing at the time. If you say, for example, double tap the one of the buttons, maybe it opens the camera. So therefore, your phone is kind of waiting for certain events like that to happen. If you're on another app, but then you decide to change the volume of the music that's playing, well, that volume button is going to interrupt the operating system and say, hey, listen, something's happened. A button's been pressed. What do you want me to do? That's an event-driven program. So yes, normal programs will run in sequential order and step by step, but sometimes there'll be an event that happens and you need to respond to that. And so events can be generated by all these different things. All right, let's look at outputs. And outputs are very similar. These are the things that are coming out of your program or function or things like that. What can they be? Well, they can be pretty much any data that comes out of a program to a device. So it's not really, there's not really limit to the output. Outputs can be many different things. It could be text, it could be audio, it could be your phone vibrating, many things. And it really just depends on what is causing that output. Would be the state or what has been saved at that time in the program, what the variables are, and what the decisions are for giving an output in the program. So the question that you might get on an exam for this kind of question would be this. you might have an example of an app, and it's asking you what is necessary that you would need to provide the app with as input to help it make a decision. Okay, and in this case, we have it's asking which one of these three would you need in order to provide a list of recommended restaurants. Okay, so I'll let you pause the video and think about it. So we've got these options here. So pause it now and have a think. And the answer is 3 only, right? Because if we just want to know really what restaurants to recommend, we really only need this thing here. We don't need Brandon's contact list because it's not about his friends. It's really just about those essential things. So that's asking for what inputs do we need. Okay. Next topic. I love this slide. Now I believe that's a repeat, but let's get back to here. Now this is an activity. Let's talk about the process. Okay, this is what we're up to. The process of developing. So sometimes you know where you're meant to be going. You have a software upgrade to do. Like you need to upgrade this software to be at this standard, and you need to incorporate the set improvements, right? Because your boss told you to, and you need to do it, right? So maybe your process is very ordered. You know exactly what you got to do. But sometimes you don't really know exactly what you're trying to do or what the result would be. In that case, it might be an exploratory kind of process. This might be an ordered process where you go from step to step, achieve a target, move to the next target. But an exploratory process maybe leaves room for experimentation, so that you might be able to chase down some wrong ways or go different ways and discover exactly where you're trying to go. The both are okay. You may also decide to use like an iterative process where you're doing feedback loops and things. But in some cases, you really need to achieve, or you need to get to a certain stage and make sure that stage is done. And I would say that we kind of, when we're doing our code, we tend to write functions this way, where we'll write a function, make sure it does the correct thing we need it to do, like for the inputs and outputs, and then we'll just leave it alone and we'll add it to our code. So this kind of thing is an incremental development process where we are making sure each part is right. We'll do extensive testing on it, and then we'll add it to the main program. All right, so we have talked about this life cycle, and I think I don't need to say much more about this other than this is the purpose of this. It has a few different stages. Some maybe take longer than others, but generally we just go around and around here. Okay, and I'm going to skip this. I don't need that. So really, when we are going to go on and design something or make a new project, we don't necessarily want to go and start coding from day one. Usually, when we're doing some kind of new project, we will spend some time investigating what the requirements are, because you don't want to have to you don't want to do a project that's so big that it's trying to do too much, or you don't want a project that's not achieving the thing you want. So some investigation may be needed. You may have to ask people, like collect user surveys, get people's opinions on things. And so these are all like things that you might do before you start a project. Okay, and this is very important because you usually have limited time or a limited budget in which to achieve things. So you have to really lock this in before you even start hiring coders or coding. So requirements. Usually the requirements describe how a program would function. It may include a description of the interactions. So you might do like a screenshot or draw a picture of the screen, and you'll say, okay, the user's going to click on here, and it's going to, do that. So you may make a list of things that the programmer might do. So this is where we're defining what it's actually going to do, like what's necessary. Okay, so really the designing is all just about how to achieve this main requirement. So we'd have to have a requirement before we knew how we're going to get and do it, right? And so that's why when we are stuck or we get in trouble or we get confused, our project gets too big, it gets confusing, we're not sure we're doing the right thing, we can go back to the requirements and see what are we actually trying to do here. Okay. So these are all interesting ways to go about the design phase. I won't read them all, but these are all kind of interesting ways to go about it. I can't see you being tested on this stuff, but you never know. I'm just going to give some examples here. So planning and storyboarding, it looks kind of like the app where you've just drawn it and you've drawn pictures, okay? And then it's just you've written on the drawing to say what each thing was going to do. And this is, this is kind of like a map of what your app would look like. And then you can have a really clear view of what you need to do, how many pages you need. The other thing I would note is that, look, let's say you're working on this with a team. If the goal is to finish your project as soon as you can, and you had this layout, well, now you could assign one person to go and look for pictures, right? Go find pictures, or, if these were all different pictures, let's say, you go find the picture, go find the appropriate picture, do different sizes, or do, work out this and that person can be working at the same time that someone else was working on the code or the other designs, right? Someone might be doing the background code, like what happens when you click a button. Let's write some code for that. So you can have 3 people working at once on this app instead of waiting and not really knowing and then finally deciding, oh, we need some pictures. We need to work out what the code's going to be. This way, everyone now can get a job and work. Okay, we'll look at that. Modules. So modules are a way of breaking code up into different pieces. And really, that's where a good function comes in, because a module, for example, this is a good example, but a module is basically a small piece of the puzzle, and each module might do a different job. And this way, you can save you save one thing from influencing too much in your code. If you put it all together in the one piece of code, it's going to get a bit complicated, and one thing might affect another thing, and they may get all confused, and then if you change this thing, it messes with that thing. You want to separate your code out as much as possible into separate pieces. And so here's an example of different modules for a system, right? We have a mail-in ballot system, we have an online ballot system. You could think of these separate things as modules, right? And you would design them in different ways. So you wouldn't want to just have one voting system where there's all, mixture of mail and online. You separate them out into different modules. We can work on them separately, and it would make things much more clear. Okay, there was a question there, but I'm going to skip that. Okay. Now, testing. Testing is a vital part of your process, because you really have to know if it works like you want it to. And you can't be the one in charge of all your testing. If you made it, you shouldn't be really in charge of testing it, because you may not test it in the ways that another user may test it. You may be too precious, or you may just have not seen something because you're too close to it. So usually we kind of we have these phases, and let's look at these kind of main modules. This is the process, okay? Requirements, brainstorm, organize modules, and then testing. Obviously, coding's in the middle there. But this is all usually done. The testing strategy is done before you actually code, because you want to know, how can I test something, or how can I come up with a plan to test it when it's done? So in a way, because you know the requirements, you should say, well, if the user can find the university that they want, then if the user can find the thing that they want, let's say they're looking for colleges, so they type in the college they want, the user should type in the college and they should get this result. Then that's a clear expectation based on the requirements. All right. So, for example, I did a cat feeder app. Let's have a quick look. So, cat feeder, okay. The requirements are: tell me when to feed my cat, give me ideas for what to feed her, keep a record of the food. The outside the requirements is to tell me where my cat is, because who knows. Now, okay, so I might make some brainstorming ideas here. This is where I can put all my great ideas, make a meow sound, keep nutrition info, warn of missing nutrition, track how much my cat likes each item. Now I've got to organize the modules of that. So I should have an alarm section, a food info section, maybe a photo gallery, popular food, and statistics. So these are the modules that I'm going to start thinking about for the different pieces of my thing. Now, testing. Well, I'm going to test on my own cat. I will maybe measure the satisfaction of the cat somehow. Get the usage stats and use the statistics to kind of see if it's working well. And then conduct some interviews and feedback from users. Okay, so that's my strategy. So hopefully now that I've done all that, I should have a good idea at how I can start designing or start coding my app. All right. So one strategy you can have is to have a predefined inputs for your testing. So you can say, I want to do these sort of inputs, and then I want to get this output, which is what I just said, like about the testing strategy. Give a category, and then you can sort of check what you expect. All right. So really, this is generally what you would have. Like, you have a set of inputs, set of outputs, and you should expect to get that. If it doesn't, then you know something's wrong. All right. Now let's look at the type of errors. And this is an important part because I have seen many questions on this in exams. So let's talk about the type of errors you can get in an app. First, you can get logic errors. Then you get syntax errors, runtime errors, and overflow errors. You may have seen overflow errors before in the data unit. Go back and check that. But logic errors are when our algorithm has an error which causes the wrong output to get displayed. Okay, or some behavior works not like you expected, right? So let's say you try to do something, you expect it should do this, and it does that. A syntax error is a mistake in the code which breaks one of the programming rules, so the language rules. So the language rules are like, well, we'll show you an example soon. Runtime errors, a mistake that happens when the program is run, so you don't see the error until the code runs, and then later it'll cause an error. Or an overflow error, which is an error that occurs when a number goes outside the range of allowable values. That's based on because things are held in a certain number of bits, and they can go outside that range. So let's look at the examples here to help you get your head around it. A logic error, when things aren't doing what they should do. For example, in this code, this is designed to add two numbers together, x and y. But it doesn't add them, it multiplies them. So that's clearly a logic error. My logic is faulty. It's not meant to be a times, it's meant to be a plus. Nothing technically is wrong, like if you look at the code, it'll still run, but the logic of my code doesn't make sense based on what I want to do. Let's look at syntax. Syntax error is the error in how you write the language, right? Because the language has rules, and you break one of the rules. So in this thing, it should say procedure, but I've spelled it predicator, And then I've used a parentheses instead of a curly brace. So that's clearly two problems here with my code. That's syntax. Runtime error. Now, see if you can find the runtime error in this piece of code. I'll give you a few moments. So, the runtime error here, if you can't tell, it's that I have a number 4. I'm saving my result here. I have a start with 4, y equals 4. Repeat until y is less than 0. Result gets divided by y. And then y less than y minus 1, so reduce y by 1 each time. If you can see here that y eventually will get down to 0. We'll still repeat. If y is 0, this will still run. And if I divide by 0, I get an error. That's a runtime error. It caused a problem. Not at first. It did a few loops, but then it hit an error. And because I divided by 0, I should have made this check repeat until y equals 0, or I should have done a while loop while y is greater than 0. But because of that, caused a runtime error. Okay, overflow errors were related to data and how we save data. In this example, we have two 4-bit numbers which we're adding together. I have 15 here, which is 1, 1, 1, 1, and these are binary numbers, by the way. And then I have 1, right? So I'm basically going to I should expect to get 16, because what's going to happen is the 1 and 1 are going to add together, and it's going to get carried. And eventually I'm going to carry it and carry it and carry it and carry it. But eventually I carry it over here, and there's no extra bit to save it because I'm using 4-bit numbers. 4-bit numbers don't allow me to add an extra bit here. Now, you say, well, why don't you use 5-bit numbers? Why don't you just add another bit? The fact is that even in regular programming, most of the time we use 32-bit numbers, which gives us about 4 billion options, right? Plus or minus 2 billion. However, that's not enough, especially if your bank balance is really high. 4 billion, not enough. And so therefore, when you think about this, I mean, every time you're using a piece of memory, it's going to run out of memory at some point. And so an overflow error is when you have that number going off the edge. Whatever you're using, 32 bits and you need a 33rd. 64 bits and you need a 65th. There's always a time when you run out of bits. So that's what an overflow is. All right. How do we fix these errors? Well, we use test cases where we use known inputs and outputs to see which causes the error, which inputs cause which errors in the output. We could do hand tracing where we're trying to use a table of all the variables and then follow the code through, like writing down the variables at each stage. We could use some software that would show us, visualize, what we're doing. Debuggers. So this is where you put a pause statement on the side of your code, and you can stop it and pause it, and then step each line at a time. Or we could just print output statements, and I like to do this a lot. I just print a lot of output statements because I coded with a language which didn't have any debuggers, and it didn't allow you to debug, and so I would just have to keep printing statements to print out and then see what was this variable at this stage, and that would help me. Okay, documentation is really important, and it's expected that documentation would be written for all of your code. Ideally, you'd write it before you write code, because you would describe what the code segment, event, procedure is meant to do. What's the purpose? This would help you to fix your code later, to understand what it's meant to do. If you come back in a week or 2 weeks, you may not remember exactly what you were trying to do with your code. So this kind of thing, very necessary. Documentation usually is going to help you when you're working on a team. It can help you in your individual life too. But usually this is because we work in teams. Someone will be handling our code after we finish. And so we need to have good comments and things like that. So comments are one way to do it. And usually, We can't always use comments. Not every language supports comments, but most of them do. And usually we'll try and use comments, and we can use double line or single line comments. But sometimes you'll provide a document, which is the thing that you're referring to when you're trying to use your language and looking up, oh, I don't remember how to do this. And you look up the docs section, that's documentation. That's what the language provides to teach you how to use it. That's what you're meant to be doing for your code to teach someone else how to use your code. Very important to acknowledge that if you've taken some code from somewhere else, you acknowledge it. If you use some data from somewhere else, please acknowledge it. You should try and use, even like if you're using pictures and other things, try and acknowledge them in the comments. Use the original author so you give proper documentation of what you've been using. All right, so here's a question on documentation. Let's write some documentation for this. What is this code doing? Write some documentation to describe what that is. So, which one is the right documentation? If you notice here, you say, well, what is this list doing? Well, we have three variables that were given as input variables. Num list. You can guess that that's a list. Then we have J and K. And you can see that J and K here are used as indexes for that list. It saves new list as num list. So we're basically taking this list and saving it into a new list. And then we say, let's save the position J with the num list position K. And let's save the new list position K with num list position J. And then return new list. So what is it doing? It's swapping the elements, J and K. These are the indexes we're swapping. Okay, so let's see which one it is. B. Right, this one. So that would be documentation. We put that in a comment at the top, and then people would know how to use it. Then you wouldn't have to read through the code and figure it out. You could just read the comment and be like, okay, cool, I know what this does. Okay, let's do a quiz. Hopefully this quiz will help you get an idea of what the requirements are for and what kind of stuff you're likely to see on a test. Which of the following is not true about a computing innovation? It includes a program as an integral part of its function. It can have a physical side to it. And a computing innovation can be non-physical. Computing innovation can be purely hardware. Purely hardware, what is it? A piece of junk. No, it's just a piece of metal. No, if it's just purely hardware, it's not really doing anything. It needs instructions. So yeah, even the video card that you buy, it looks like it's just a piece of hardware. It has software which runs it, drivers and things like that. So yeah, we need. You can't just have purely hardware. What is a program? Collection of statements that perform a specific task when run by a computer. Collection of program statements that are part of a program. How software behaves and how it functions. A code segment. And the answer is A. Collection of program statements that perform a specific task. All right. When designing a program, what are some ways to determine the constraints and needs of the users of the code? Constraints and needs of the computer. So, could we collect interviews? Could we collect information through surveys, interviews, and focus groups? User testing of the prototypes. Writing elegant code which is free of errors. Okay, we're trying to find the constraints and the needs. Elegant code doesn't come into it. So let's look for the one that says 1 and 2 only. That would be C. All right, next one. What is the main purpose of assembling a diverse team when working on a project? Diversity makes your team less likely to create errors and therefore reduce the need for software testing. Diverse teams will always come up with better solutions to problems. diverse teams promote social justice, and this is necessary for society. Or D, diversity of background and experience can give a team different perspectives on a problem, which may improve the results. Well, if you guessed D, you're right. Okay, it can give a team different perspectives, and it may improve the result. No one's saying that diverse teams are going to come up with the best answer every time. But, and we still have to test. But it does help us to get different perspectives, which may help. All right, what is not a likely cause of an event being generated in a program? A, user clicks an icon. B, another application makes an API call to the program. C, program runs on a phone and the accelerometer detects a change. D, the program displays a message to the user on the screen. What's not likely cause of an event? That's outputs. Okay? Displays a message to the user on the screen is an example of outputs. Okay? An event is usually generated from some kind of inputs. And so that's what events are all about. Okay? So, the API, this is an application program interface, which means APIs are when a program has a way to talk to another program. And so if programs provide a way for other programs to connect and talk, and they run functions, they run maybe a procedure from another program, that's an API call. All right, what type of error will the following procedure cause? Now, we just covered errors, so hopefully you remember what kind of error is this. Is it a logic error? Is it a runtime error? Is it a syntax error? Or is it an overflow error? It's a syntax error. Why? Well, what is B? Well, B is the input here, input variable B. But what is A? A is nothing. A doesn't mean anything in the language. Therefore, we've broken the language rules. We've used something that doesn't apply in the language. So we would say, hey, what is A? You've used the language incorrectly. The following procedure is meant to add the two input numbers together. What is the error? Logic, runtime, syntax, or overflow? Well, this is illogical because it's A minusing B instead of A adding B. It's meant to add the two numbers together, so it doesn't. Logic is wrong. And finally, what type of error will the following procedure produce? We have an error where we're going to repeat 4 times. What is going to happen? Logic error, runtime error, syntax error, overflow error. Well, this is, if you want to pause, you can pause now. This error is an runtime error. Why? Because we repeat 4 times, we go through our list, but we only have 3 values in the list, so that we're going to try and access a value that's outside a loop, outside the list, and therefore we're going to get an error trying to access number 4 over here. Not a good idea. So that's going to hit runtime error when we do the 4th loop. All right, so there were the answers. All right, so don't forget, if you do get kind of confused on any of these concepts, go back through the Big Idea Guide. There's a bunch of points here. These are all the points that they're testing you on. So I'll just skip through these now. You can pause the video and see them. These are all the concepts. You can certainly look through them all. This is basically what I've been covered this time. And this is what I've been basically covering from the Big Idea Guide. You can get these guides from College Board site, and this is what we've been going through. It contains all of those concepts in here, and they may help you study as well. So, thanks for joining. It's been great. I think I came in under an hour now, so good luck for the exam, and I hope that your creative developments are fruitful.